All right, let's go ahead and get started. So, it's just a simple multi-step equation. And the reason that I've got it formatted the way I do is because this is going to be pretty much what we're looking at to solve, okay? So we're going to start off by combining like terms and simplifying. Two times 5 times 6 is 60. Going to subtract and divide, right? We've got it down to a two-step equation now. We're going to subtract and divide. Subtract the 20. And then divide the 60. And we'll notice that there's a factor of 5 from the top and from the bottom. So we'll be able to say 5 divided by 5 is 1. 60 divided by 5 is 12. So here the answer is 1/12 for this one. Then we can go through and do the same thing for this one. We've got 12 plus 4 is 16 equals 27 plus 2 times 3 times 7. Either way you go about doing this, you get 42x. And then we've got it down to a two-step equation, so let's simplify. Subtract the 27. Get negative 11. And then divide by 42. And we end up with, because 11 and 42 don't have anything in common, negative 11 over 42, right? We can't simplify that any. So we're stuck with leaving it like this for that one. All right. So why am I making you do stuff like this? Well, what does this have to do with what we're about to do? So when we go through and do problems like this today, it's going to be that's sort of the form that we're going to be working with. The law of cosines, which is what we're talking about today, also known as Al-Keshi's theorem. And the old mathematician Al-Keshi was the one who initially came up with this in a form. So, back in those days, there was no concept yet of sine, cosine, and tangent. And so it was written in a different way. You'll see that there's a cosine in our formula. And that was done in a more modern way, but the initial idea, the initial concept, the initial situation that was given was figured out by, I believe he's Egyptian. I'm going to look just to make sure because I don't want to. I take that back. He's Persian. He's from Iran in the 1300s. So I was completely wrong. He is from where modern day Iran is. This man, when he came up with it, this is before the concept of sine and cosine and tangent. And so more modern mathematicians have taken his work and they've changed it to suit our needs. But make no mistake, this is the person that discovered what we in our textbook call the law of cosines. Outside of the United States, you're sometimes more likely to hear it called Al-Keshi's theorem, but we in our book refer to it as the law of cosines. But it's important that we know our history, right? So how are we going to do this? The key to doing this one correctly is knowing which angle we're going to use, because there has to be one angle that we are using in our formula, and you'll see as we go through. But if you don't correctly identify where the angle that we're using is and what the orientation is, it's going to be a problem. If you get the orientation, you should be fine. All right. So the other thing I want to talk about as I turn the page here is that the way the book does it kind of subverts intuition. What do I mean by that? You're kind of going through and saying, you're kind of going through and trying to make sense of this theorem, and it's hard the way that they write it out. To me, the easiest way to think about the law of cosines is with the Pythagorean theorem. We know what the Pythagorean theorem is. A squared plus b squared equals c squared. Now, that's only true for right triangles, right? But we talked before about how we can use the Pythagorean theorem to identify acute triangles or obtuse triangles. And the fact of it is, if we had like a second little thing after the c squared that sort of helped line everything up, then we would be able to use it all the time. Well, this is what the law of cosines does. It takes the Pythagorean theorem and puts a little bit of a plus this to make it work for everybody. Okay? So I'm going to show you how the way that the book lays it out, less than ideal, generally speaking. So this is just rewriting the law of cosines in 3 different ways. And they do it like this. They have it solved for a side and using the perspective of the side to work through the triangle. Now, I think, this is me, I think that it's much easier to do this through the perspective of the Pythagorean theorem. Look what I mean. See how everything's kind of all over the place? If I go through and I rewrite the law of cosines to make it match my expectations, right? This is the Pythagorean theorem right here. A squared plus b squared equals c squared. Look at how well this last half works. So first of all, it's on the wrong side, so we basically just add it over to the other side. So plus 2 side A, side B, cosine of angle C. Remember, only angles go into the cosine. So now look how everything's set up. ABC plus ABC. So it's the Pythagorean theorem plus 2AB cosine C. Now, the best part about this theorem is that it works no matter what. We don't need to keep it in this order. Like if we want to work, because this one assumes that I have angle C to work with or find, right? Well, what if I don't have angle C? What if I have angle B? Well, then I can flip it around. So the best part is, see, I always like to work from the angle backwards because I already know that this is going to be like a Pythagorean theorem type thing. So look, let's say I want to use angle B instead of angle C. Well, what's going to go here? What's the other 2 letters, right? 2AC. This letter goes with this letter, right? And then now it's the other 2. And you can use this situation so much easier than if you have no concept of how it relates to anything. Like you could sit here and memorize all these. Sure. But that's just more information that's going to be taking up space in your brain. If you remember this part. If you remember, base it on the angle. Pick the angle that you want to use or that you want to find and work backwards from there. You'll always get it right, and it'll be a lot less work for you to do. That's a promise from me to you. Let me show you what I mean. So look, I'm going through and I want to figure out using the law of cosines. I want to get this. Well, this is the angle that I have, so I have to use this angle. Well, what angle is that? That's angle B. So let me work my way. What are the other two letters? A and C. This B goes with side B. Then the other two letters, A squared and C squared. So look at what I have. I have written the law of cosines formula. And it's so much easier because I started with the angle. Angle B. Okay, that's where I am. I work my way back. The other two letters are A and C. Then repeat. B, A and C. B, A and C. B, A and C. All right. And the letters could be anything. It doesn't have to be A, B, and C. It could be X, Y, and Z. Q, J, L, whatever. Doesn't matter. But now I can do this. So look, what's what here? Here we got big B, right, is 44. Little c is right here. Little a is right here. And little b, that's what we're trying to find, right? So let's plug everything in where it goes. We got a is 22, so 22 squared plus c is 10, so 10 squared equals thing we're trying to find squared plus 2 times a times c, so 2 times 22 times 10. Cosine of big B is 44. Remember that the angle is the only thing that's allowed on the inside of the cosine. Nothing else goes there. I don't care what you have or what you think you have. If it's an angle, it's allowed. If it's not an angle, it ain't allowed. So what do I do here? This is a lot of work. Well, luckily, the calculator is all ready to go for us. A bunch of this stuff I don't want to do in my head. I don't want to do 22 squared. What's 22 squared? It's 484. All right. So look, what do I got? I got 484. 10 squared is 100. This stays put. 2 times 22 times 10. 2 times 22 is 44. Times 10 is 440. Now you're looking at this and thinking, oh, I can do stuff here. No, don't. Don't bother. Leave it alone. If you try and figure out what 440 times the cosine of 44 is, you're going to get some big, long, ugly decimal like 99% of the time. Ain't nobody got time for that. Leave it alone. Just leave it alone. I'll show you what I mean. Just pretend like this is just a big thing. It's less to write out than a big, long decimal that I would make you write if you did it. So we got 484 plus 100. That's 584. Then I want to get b by itself, so I'm going to subtract this monstrosity over here over. And that's equal to b squared, right? So I added these together. I subtracted this over. Notice it all came over as one unit because 40 times the cosine of 44 is a number already. Don't try and be fancy. And then the last thing we're going to do is we're going to square root both sides so that we get b by itself, right? So we want to know, what is b? Well, let's put it in the calculator and find out. So I'm just going to put it right in the calculator. Square root of what? 584 minus 440 times cosine of 44 I'm going to close the parentheses. That's what this is, right? So that's what we do. Hit the enter button. That's our answer. 16.35513644. Now we look up at our task here. It says find b to the nearest tenth. And since we're doing it to the nearest tenth, we're going to draw a line after the tenth place, chop it off, and see what's going on here. That's a 5 in the hundredths place. So that means we round this up to what? 16.4. Final answer. Same idea, same problem. It's just they change the orientation and change the numbers. Alrighty, let's go ahead and go over this problem. So once again, let's identify what it is that we're looking for before we do anything else. They want to find MN. That's this one, right? So now that we've done that, let's identify our angle that we have to work with. 104. Angle L, right? So let's write that out. Cosine of L. And again, let's label our sides. This is little l, little n, little m. So the other two letters, 2 and m, plus these should match, equals that. Hey, we did it. So now let's fill everything in. N is 48. M is 29. L is our thing that we're trying to figure out. Now you can leave it as L, or you can put in X or whatever variable you want. I'm pretty interchangeable. It's whatever. 48 and 29 go here. And then the angle L goes in the cosine. And there we go. So now we're going to take care of all these silly numbers. Now, once again, I'm sitting here thinking, well, I don't want to do a lot of this work. Let's have the calculator help me out. What's 48 squared? What's 29 squared? And what's 2 times 48 times 29? All right, so now I've got my numbers. That'll allow me simplify everything out a lot. So 48 squared is 2,304. 29 squared is 841. This mess right here, these three numbers make 2,784. And now let's do the exact same thing we did previously. We'll add these together. And this will give us 3,145. And then equals x squared plus 2,784 cosine of 104. And now we've done that, let's subtract that over. Again, notice I'm doing like one little thing each time. Just one little thing each time. And, you don't necessarily have to do this yourself this exact way. I'm not going to stop you from moving a little bit faster if you feel comfortable. But if you don't feel comfortable, look at how easy this is to just write it out. No actual effort here. to do this. And now it's just put it into your calculator, right? So what do we got? We got the square root of why is it that everything else stacks but the delete button doesn't? 2784 times cosine of 104. Again, that's just what we wrote here. Calculator ready form, ready to go. And you just hit the enter button and voila, you've got your answer. 61.794098808. So we can just do that and write it out. And then we look back up and it says round to the nearest tenth. Well, let's do that. Nearest tenth, here I chop. That is 5 or bigger, so we're going to round this up. And so this final answer here, 61.8. All right. Same thing as before. Don't let this freak you out. And obviously I'm going slow to talk through it, but this shouldn't take you longer than it takes you to physically write it, to be honest. If you just write everything down, do one step at a time, just write it down and write it down, shouldn't take you more than a minute to do one of these. Now we're going to find an angle. Same idea. We have to write it out so that we use the angle we want. If I don't have an angle, I have to pick the angle I'm going to use. And here they do it for us. They give us the 3 sides, and then they say, find the measure of angle V. So I better be using this guy right here. So once again, start with your angle. And let's label all the rest of these T, U, little v, right? So what are the other 2 letters? We got T, U, plus the side V squared equals T squared plus U squared, right? Again, make sure that the letters line up. TUV better also be TUV in it. Whatever this letter is here in the angle better match up with this. And then T and U are the remaining 2. T and U are the remaining 2. So much easier to remember it like that, I promise you. All right, let's write everything out, plug it in. 7.1 squared plus U is 6.7 squared equals little v is 4.4 squared plus 2tu 2, 7.1, 4.4, I'll be able to write correctly someday. Cosine of the thing I don't know. Maybe just call it V so we've got what we want. Now, again, am I going to sit here and am I going to calculate all these out by hand? Absolutely not. This is what calculators were invented for. 7.1 squared. 6.7 squared. 4.4 squared. 2 times 7.1 times 4.4. See, now I've got all my numbers here. Let's move on. 7.1, so we got 50.41 plus 44.89 equals 19.36 plus 62.48 cosine of v, right? Let's combine all our like terms. Be like 95.3, right? Can I add those together? I don't trust myself. I'm gonna do it in the calculator because I don't want to make a mistake. Again, this is sort of thing. You've got it all right here. Hey, I was right. See, I should have trusted myself. I'm better than that. But I will say there's something to be said for not trying to do all this mess in your head. Especially when there's this many decimal places. It's okay. So now let's subtract the 19.36. $75.94. You got 75. See, I did something wrong here. And I know I did something wrong. Here, I'll show you how I know. I know I did something wrong because this number is bigger than this number. If this could be positive or it could be negative, this number that I've got right here, the 75.94. But in order for this to be correct, in order for this to be possibly correct, this number's absolute value, whether it's positive or negative, has to be less than whatever this is. Because cosine only operates between -1 and +1. The reason for this is because of, and you'll talk about this when you get to pre-calc and trig, something called the unit circle. Cosine and sine represent the percentage of the radius of the circle that you're actually using at an angle. So if it's 100%, then that's 1, right? If it's negative 100%, then it's -1. And so the sort of the percentage of the radius that you're actually using on the unit circle goes from negative 100% when it's down negative, and then positive 100% when it's up positive. So now I need to figure out where I made a mistake. Did I do this part right? 7.1 squared is in fact that. 6.7 squared is in fact that. 4.4 squared is in fact that. So all that's written down correctly. Two times 7.1 times not 4.4. Oh, there's my mistake. See what I did wrong? That's supposed to be U. I put V. This is why we double check our work, right? So that shouldn't be 4.4. That should be 6.7. See, we all make mistakes sometimes. Especially me. So now let's clean these up. So I've got to figure out what 2 times 7.1 times 6.7 is. Two times 7.1 times 6.7 0.7, 95.14. There we go. See, that makes more sense. So you go through here and you say to yourself, I look here, this number is smaller than this number. So I'm doing all right so far. So I'm going to divide that 95.14 over. And again, don't try and actually do the division and get the ugly number that results, because you're going to be putting this in the calculator anyway, right? Why bother? So you're going to also take the inverse cosine of both sides, because we actually want to crack it open and find the value of the angle. So it's going to look like this. So now I've done this. I've got it in my calculator ready form. I'm going to throw it into my calculator and go ahead. So second cosine, remember you want to see that inverse in there, right? Second, that -1. Then you're going to type it in, 75.94 divided by 95.14. Close those parentheses. And that's my answer. 37.04219062. And there we go. So now we look back up here and they say to the nearest tenth. So let's make sure that we are following directions. Nearest tenth. This is a 4. That is too small, so these round down. So we're left with 37.0 degrees. All right. And that's it. See, again, simple steps. Easy to tell whether you've done it right or not. Easy, especially since you're doing 90% of it in your calculator already. Don't make life hard. All right. So here's your problem. You'll notice it's the exact same triangle, right? I found angle V. You're going to go ahead and find angle T. That's your turn now. All righty. Let's go ahead and go over this one. So remember, now it's the same exact thing, but we want to find angle T. So let's write out our law of cosines for dealing with angle T here. Always start out and help yourself by labeling everything up. So look at what we got. What are the other things here? U and V. Then if this is T, this is T. Then here's the U and the V. So now let's plug everything in where it goes. U squared, 6.7 squared, which we already know because we already did those calculations. Let me just pull these back up here. We did these back for the last problem. Why do more work than is absolutely necessary, right? U was 6.7, so U squared is 44.89. V is 4.4, so V squared is 19.36. T is 6.7, so oh, T is 7.1. What am I saying? T is 7.1, so that's 50.41 because we're squaring it. 2 times u times v. That's the only one that new that I have to do. So let me do that one. So we got 2 times u times v, 2 times 6.7 times 4.4. That's 58.96. What I'm trying to find is angle T, so that stays put. So let's add these up. Got 44.89 plus 19.36. That's equal to 64.25. And again, don't try and combine these like terms here. They're not like terms because this is a number and this has a cosine t on it, right? So subtract the 50.41, get 13 point something. All right, so we do that, we get 1384. 64.25 minus 50.41, 13.84. And we look here, this number we got here, much smaller than this one. So at the very least, we're going to get an answer. That's good. I'm going to invert the cosine. And we're going to plug that in. So we got, again, inverse cosine. So second cosine. Make sure to close your parentheses. And that'll get you your answer, 76.42397.316. And then we follow directions and we say to the nearest tenth of a degree. So we look again at that nearest tenth. Look at the number after that. Less than 5. So we round down. So our answer here, 76.4 degrees.